Hi everyone, welcome to channel Qtomation. In last session, we have started with test cases design techniques. We have also seen what is exactly design test techniques. So test design techniques are methods used to prepare test cases with different test data and scenarios to ensure that software is thoroughly tested. These techniques help in creating structured and efficient testing processes. Since exhaustive testing is not possible, testing techniques help to reduce the number of test cases to be executed while increasing the test coverage. So this is basically a test design technique. So there are mainly 5 test cases design techniques which are used in black box testing. In last session, we have already seen about equivalence class partitioning. In today's session, we will see about boundary value analysis. So, boundary value analysis is kind of an extension of equivalence class partitioning. Boundary value analysis is used with equivalence class partitioning as well. So, let's see in detail what is boundary value analysis and how it can help to design the test cases. As the name suggests, boundary value analysis. It is a software testing technique used to identify errors at the boundaries of input ranges rather than within the ranges themselves. The premise is that errors are more likely to happen at the edges of input domains. So let's say we have one range of test data. So in boundary value analysis, it is basically testing out the boundary values because it is more likely to happen that errors will occur at the edges of that input range domain. So we have to test the values which are at the boundaries. These are the values at the edge of input range. Let's take a simple example. If an input field accepts values from 1 to 100, let's say on website we have one input field which accepts the values from 1 and 100. So what would be the boundary values? So boundary values would be 1 and 100. Just below 1 that is 0, just above 100 that is 101, and the values which are just inside the boundary that is 2 and 99. So how many boundary values we have got for the range of 1 to 100? So if there is an input field which accepts the inputs from 1 to 100. So as a tester, if you want to test out, are you going to test out for all the 100 values? For example, 1, 2, 3, 4, 5 and so on up to 100. It would be exhaustive for testing. So instead of testing for all the values, we have to focus on the boundary values. And what are the boundary values? So boundary values will also consider some positive values and negative values. For example, for range of 1 to 100, what are the different boundary values you have to consider? So first would be 1 and 100. That is obvious. 1 and 100. Value less than 1, just below less than 1, that is 0. The value which is above than 100, just above than 100, that is 101, which is present at the boundary. And the immediate values which are just inside the boundary, that means 2 and 99. They are inside the boundaries. Just after 1 there is 2 and just below the 100 there is 99, which are inside the boundary range. So we have to consider the boundary value, one value lesser in the boundary range and one value more in the boundary range. So these are the 6 values we have to consider for boundary value analysis as a test input. So we have to test for all these 6 values as a boundary value analysis. Boundary value analysis is often used in conjunction with equivalence class partitioning, which we have already seen in our last session. In ECP, that is, while using equivalence class partitioning, what we do, we divide the input data into partitions of equivalent data from which test cases can be derived. So we divide the test data into valid classes and invalid classes, and we pick one values from them. So in boundary value analysis, we can basically use the equivalence class partitioning, in which the data will be divided into some classes, and then we can pick the values from the boundaries. Each partition represents a set of values that are treated the same by the system in equivalence class partitioning. And in boundary value analysis, it is the next part of ECP. So what we do, test cases are selected at the edges of the equivalence classes. So we have to select the test values at the edges of the equivalence classes rather than finding those that exist in the center of the input domain. So we will see one example, in that we will get better idea about it. But just understand, we have to divide the test data in equivalence classes, and then we have to pick the boundary values. So earlier in equivalence class partitioning, we have seen we can put any input from that range. But instead of that, in boundary value analysis, we focus and we pick the values which are at the boundaries. So every partition has the maximum and minimum values. And these maximum and minimum values are the boundary values of a partition. So boundary values, we have to focus on boundary values of that partition. So boundary value analysis focuses on testing both, that is valid as well as invalid input parameters for the given range of software components. So we have to pick the values from valid as well as invalid input range as well. So let's see one example, then we will understand in better manner. So what are the steps to perform boundary value analysis? First step is we have to identify the boundaries. We have to determine the minimum and maximum values for each input field or condition. After identifying the boundaries, we have to consider the boundary values. So there are three types of boundary values. One which is present exactly at the boundary. Let's say range is from 1 to 100. Then 1 and 100 are the exact boundary values. Also, we have to consider values which are just inside the boundary and values which are just outside the boundary. So we have to also consider minimum plus 1 value, minimum minus 1 value, maximum value, max plus 1 and max minus 1. So these are the 6 values we have to consider. And then we have to create the test cases using those boundary values to ensure that the system handles those boundary values correctly. Now let's take a simple example. Let's consider there is a form. There is one form about user details. In that form, there is a field called as an age. Now age accepts valid values of 18 to 60 years only. Now that is the range of valid values. So only the users in the range from 18 to 60 years have the possibility to create the account. So it is valid for the users whose age is within 18 to 60 years, including 18 and 60. It should be allowed only for 18 to 60 years. So only integer values are allowed as an input. So what is the boundary range here? 18 to 60 is a range. Minimum value is 18, maximum value is 60. So if you see, we have got minimum value, we have got maximum value. Those are the two values we have got. That is the minimum boundary value and maximum boundary value. So two values we have received, that is 18 and 60. So 18 years, 60 years. This is the valid range of input. 18 years and 60 years is the valid range of input. And now, what is the next step? So we have got two values now, 18 and 60. We have to also consider the value which is just inside the boundary. So 19 years, minimum plus 1, that is 18 plus 1, 19. So 19 years, also 60 minus 1, that is 59 years. That is also inside the range, just inside the range. So 18, 19, 60 and 59. These four values we have got for boundary value analysis. And we have to also consider the values which are just outside the boundary. So 18 minus 1, 17 and 60 plus 1, that is 61. These are also two values which are just outside the boundary. So we have to consider these values as well for boundary value analysis to design the test cases, because it is considered as a negative test case, invalid input that should be handled correctly. So if you cover these six values, that is 17, 18, 19, 59, 60 and 61, these are the values we have to cover for boundary value analysis. So we have to test that input field with these six values. So for 18, for 19, for 59, for 60, these are the positive test cases. For this range, that system should accept those values. But the value of 17 and value of 61, system should show some error to the user. But they are still valid test cases because we are testing the negative scenarios. With that range, the values which are less than 18 and values which are greater than 60, these are the values which are outside the boundaries, just outside the boundaries. So this is called as a boundary value analysis to design the test cases. So we have to design the 6 test cases here. So for the boundary of 18 and 60, what are the boundary values we have received? 17, 18, 19, 59, 60 and 61. 18 and 60 are minimum boundary and maximum boundary value. They are still valid boundary values. Values just inside the boundaries. Which are the values which are just inside the boundaries? 19 and 59. 19 is just above the minimum boundary and 59 is just below the maximum boundary. And which are the values just outside the boundaries? 17, which is just below the minimum boundary, and 61 is just above the maximum boundary. So we have to cover these two values as well as a negative test cases. So these are basically boundary value analysis, and we have to test all these 6 values to ensure that our input range is working correctly. So this is the simple example of boundary value analysis. And what is the benefit of boundary value analysis? Detection of defects and vulnerabilities using boundary value analysis. So if there is some issue for some type of test input, we can find out by using boundary value analysis for the input ranges. It also improves the test coverage with boundary value testing. It increases the accuracy and efficiency with boundary value analysis. Overall, it enhances the software quality and user satisfaction. So this is about boundary value analysis. So we have to focus on boundary values. If there is a range of 18 to 60, what are the boundary values? Just inside the range, that is 18 and 19, 60 and 59, and the values which are just outside the boundary, that is 17 and 61. So this is about boundary value analysis. It is also one of the test cases design technique. It is used in conjunction with equivalence class partitioning. So after partitioning the class, we can found the boundaries. So we have to identify the boundaries, and after determining the boundaries, identifying the boundaries, we have to determine the boundary values. So the values which are present at exact boundary, just inside the boundary, and just outside the boundary. So these 6 values we have to consider for boundary value analysis, and we have to test the system with those 6 values, and that will cover the entire range, valid as well as invalid input range. So thank you for watching this video. In coming session, we will see about decision table, that is the third type of test case design technique.